And welcome back. Now today, if we're looking at this workbench here, there's a few items on here that I'm going to build into a project. Now really it's a sort of child's bedroom light, but with a twist. Now normally when you think of a night light for a child's room, it's just one of these plug-in units that displays a dim white light, well, yellow anyway. But these are going to be different. Now these little tiny white things here, these are in fact 1 watt deep red LEDs, 650 nanometer wavelength, if I remember correctly, but we'll check that out later in the video. And they take 2 volts and about 140 milliamps, maybe something like that. Anyway, now I've got 5 of these, and I've tested these out, and these are really bright, too bright. In fact, just one of them by themselves. And I've got 5 because what I want to do is plug those in to a 12 volt supply with a small limiting resistor, plug it into an Arduino, use the pulse width modulation pins, which on here you can see are the ones with a little squiggle on, so you got 3, 5, 6, 9, 10, 11. So I'm going to pulse width modulate these LEDs, except of course how are you going to adjust the brightness in the middle of the night when I want to create all this as a little tiny self-contained project, plug in 12 volts well into here and run this entire project from that. How do I adjust the brightness overnight? And that's where this comes in. This is, as you can see here, a 4-button RF remote control. So this is just a little key fob like you might have on your car. So A, B, C and D, the 4 channels. And here you have a little tiny receiver with 4 outputs. If I can get close enough and focused in, thank you. Right, so you can see there's ground and 5 volts at the top, and then D0 to D3, which are the outputs, and VT, which if I remember rightly goes high whenever any of the buttons are pressed to show you've got a signal. So you could connect that out, say to an LED or something, to show that you've got a signal being received. A bit like what you get on your telly when you press your remote control. You often get a little light come on. So I'm going to use, well, at least 2 of these channels, one to increase the brightness, one to decrease the brightness. And as I've got 4 channels on here, I thought, well, then I could have another one like full brightness, another one all off. We'll see how that pans out though, because I haven't quite decided on that yet. And although I'm going to develop it using this DDC Arduino, or possibly my Nano on a development breadboard, which you've seen in other videos, it's going to be built up using something like this. It might not be these actual units, but something very like it. This is a Pro Micro, and this one is some kind of Nano. Oh, they are Nano 3, so that is a Nano in fact. Now as you can see, these are tiny. I mean, they require far less room than this, and I've ordered from Banggood a transparent project case, or at least the lid is transparent, so that I can put all this inside it and have these LEDs then shining through the lid. So eventually I'm going to end up with a little tiny box, probably about that big, which I can stand up, have the light shining through, one 12 volt in, and using this and this to control the brightness. Right, that's the starting point, and I had to film this before I started connecting things together, of course, so we'll see how many days, weeks and months it is before I continue with part 2 of this little intro. Well, just a minute, just before I go, I was going to show you where I got those radio bits from, the receiver here and the transmitter. Now funnily enough, it wasn't from Banggood, it wasn't from GearBest, it wasn't from eBay. It was in fact Adafruit, but via a supplier in Britain. Screen, here we are. Now this is the receiver. It's a momentary type, which means of course as you press one of these buttons on here, the output only stays high for as long as you press that button. As you can see, big red discontinued across it now, because I'm guessing Hobbytronics, where I got it from, don't make it anymore, or don't supply it anymore, but I'm sure Adafruit or another supplier supplies something very similar. And the transmitter is that one there, also discontinued, 4-button RF remote control, also discontinued, but believe me, you can get these anywhere from the Far East by the dozen. Now, just one word though, when you look at the specs for anything like this, I've got this one here without any relays, because you obviously can pick up this with relays already attached. Makes it a little bit bigger, but that notwithstanding, I don't want relays attached here, because obviously they make a huge clicking sound, and in the middle of the night that would be very, very audible. So if you're turning the brightness up or down, that would be terrible. Click, 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 that'd be awful. So you want it without any relays attached. So just thought I'd let you know. Oh, the other thing is, there's no learning button on here. Quite often you get these little transmitters, and there's a little learning button on here. You press it for each one of the buttons, and then this remembers and is locked to the transmission. On here, I guess it's a simpler design really. It just is tuned, I guess, at the factory. This little coil here is probably already tuned up. So there's nothing to do on here. There's no setup or anything out that works, or it doesn't, and I've just tested it and it works just fine. Obviously the range I'm talking about is maybe, what, 10 feet in the bedroom if you have something on the bedside cabinet like this, or perhaps you might have it by the door if it's your child's bedroom, so you can just turn things up or down, whatever. That's how it is. So, nearly forgot to tell you about that. So, right, I'll see you when I've got some more of this built up then. Great, see you then. Right, here we are a day or two later, and I've got a sort of a prototype knocked up. Now this is a bit flying by the seat of your pants because there's nothing official about this just yet. I just thought I'd show you how far I've got so far. So what I've got here is a standard Arduino, well, DDC Arduino, powering logic level MOSFET here. We'll talk about that in the actual project a bit more. I've got a couple of switches so I can dim things up or down, and I've got a little capacitor here that serves as a sort of a smoothing effect from the pulse width modulation that I'm using, because I don't really want short, sharp pulses of electricity going into here. I want it sort of a little bit more smoother. And what I'm going to try and do is get the picture of what's coming out of the MOSFET here on the oscilloscope in the main project. But I thought I'd just share this as I'm going through it because it's quite interesting. So what I've got here then is a couple of switches where I can fade things up. So if we look at the this LED, there it goes, look, nice and bright. And fade it back down again. Now remember, this is from a child's bedroom, so it's going to be pretty dim most of the time. It's amazing how bright a single LED, a standard LED, and never mind one of these 3-watt jobbies, a standard LED is at night. I don't know if you've got a TV in your bedroom, for example, the standby light, the red standby light, can actually be quite bright, dazzling almost at night time, if it's in your line of vision. So I know that from that experience, these are going to be pretty dim, even though this is going to probably be placed at the top of a wardrobe. I'm not going to want them very bright. That's why I've actually got 5 of them, which I'm going to string along in series and drive it from 12 volts. Because I want a gentle glow rather than a strong source of light coming out. So this, in principle, is exactly what I want. These switches, of course, will be replaced by the remote control module. These will be the outputs from that remote control receiver. So as I press the button on the remote control, it'll have exactly the same vectors here. That one will turn it up and the other one will turn it down. Now what the effect of that capacitor that you see there is that you get a much smoother range here on this LED. Once again, you're seeing this LED as a sort of a white thing with some red reflections here, I notice. But this is a real eye-searingly red colour. Well, it's deep red. I think it's 650 nanometers. Can't remember, I'll have to look it up. I think it's 650 to 670, something like that. So it is deep red, which is great. Now you might say, well, why did you choose a deep red light? And the reason for that is, I mentioned at the beginning of the video that most kiddies' night lights, or any night light, is sort of a very dim whitish yellow light. Which is, yeah, so, but as I say, if a single LED from your standby LED on your telly can be bright enough, then those kiddies' night lights are in fact too bright. Well, I find they are anyway. So I'm guessing, well, a bit more than guessing actually, that red, being a very dark colour, if that's the right expression. It's sort of at the end of our spectrum, isn't it, that we can see. The next step after this red is in fact infrared, which we can't see. So this will enable me to give somehow a strange sort of light in the bedroom. It enables you to see, but when you shut your eyes you can see nothing. It's not like a white light that can penetrate through your eyelids. This will give us a light that lights up the room very, very gently, and you may have to shut your eyes for a couple of minutes in a dark room and then open them to see the effect. But this will give me a nice deep red glow that's almost imperceptible, but you can see in it. As I say, I've tried it out very briefly, so I'm sort of know what I'm expecting. So in principle, this is what's happening. I can show you the code window for this. It's that one. Right, there we are. This is the window. So this is the code. There's not a lot to it really. In fact, yeah, that is it. So what I'm doing is, well, okay, at the beginning I'm defining a couple of switch up, switch down. Back to here. So the pin up, no, actually that's pin up, that's pin down. They're going into over here on pins 7 and 6. Okay. The pulse width modulation pin I've chosen is 9. As I say, only some of the pins over here do pulse width modulation, but 9 is one of them, so that's fine. Okay, that serial begin, that's just for debugging, so I can display the output. I'm defining the input pins as pull-ups, of course, because normally they'd be open-ended normally, and I'm hoping that on the remote control there may be something coming out. If not, it doesn't really matter. I mean, I could even use a diode, frankly, from the output of that remote control. It's just to get a signal in. Okay, this is my fading value. I've just started off with a 10. I'm using a static int here, so that effectively when you use static int or any static type, the compiler actually moves this out of the loop. So it declares this outside of the loop and then retains its value as you go in. So I'm pretty, well, I'd guess that it probably moves this into some sort of global domain, except that it's only, the scope of which is only within this main loop. So you get the benefits of a global variable, but still scoped within loop, and it's not floating about everywhere. I don't like global variables too much. So I'm saying whilst the pin for fading up is pressed, that is, it's pressed to earth, we fade up until we hit a maximum of 255, which is what pulse width modulation can take. That's maximum. And when you press the switch down to earth again, or to ground, it will reduce that until it goes down to 0, then keep it there. If you look at the, can I show you this? Was it not gonna? Right, this is the serial output window that displays the value of the pulse width modulation. So what I need to do is show you that and the workbench all in one go. So just one sec. There we are, that's much better. Now you can see the code, the serial monitor or debug window as I call it, and the workbench all in one go. So at the moment it's set to 32, which is sort of a, I'll be surprised if I ever get up to 32 in a dark bedroom, frankly. That'll probably light up the whole room, even though here it just seems not much at all. So if I press the down switch, there we are, the pulse width modulation goes down, and after about 23 I think it actually goes off. Now that's the, I can just make out on there a little tiny glow. I think you probably can do as well. It just looks like somebody's coloured something in red. And that's at 24, so I can bring that up. Here you can see the serial window going up. I don't want to do any more than that because I haven't got any kind of limiting resistor or anything on here at the moment. So I'm probably pushing the boundaries even as I'm doing it. And there it goes back down again. So that's the principle by which we're doing this. Up and down. It's, you know, it's, well, I mean, effectively that is the prototype, isn't it? I mean, that is exactly what we're going to do. So when I get this a bit more sorted out with the remote control, and that box should be arriving, the transparent lidded box should be arriving within a week because it's been sent from the EU warehouse, I'll plug all this in again and see where we go from there. Right, that was my prototype that I'm happy with. I can just dismantle all this now I know it works, and I've determined the value of this capacitor that makes it nice and smooth on here. So that's it. Next time you see this video, it will be another stage moved on. Okay, see you in a little while. Come and join me in part 2 to see how the project moves from this prototype stage to its completed stage. Look at this, I mean it's actually done. So join me in part 2, come on over, it's the next video in this series. I'll see you then. I hope you're finding these videos interesting and useful. You can leave comments down below and also click that little button that says subscribe. Okay, thanks for watching and see you in the next video.